presence of polar bonds in a molecule may or may not cause the entire molecule to be polar. A polar molecule means that one entire end of the molecule is partially positive and the other end is partially negative. It has a dipole. So in water, you can see that one side is positive, the hydrogen end, and one end is negative, the oxygen end. The presence of polar bonds in a compound does not mean the entire molecule will be polar. If a molecule has polar bonds symmetrically arranged around the central atom, such as in carbon dioxide, the charge centers will cancel themselves out and the molecule will not be polar. In carbon dioxide, we have oxygen on the outside, so we have negative on the outside and our positive in the inside. So to help simplify things, here are some questions you can ask yourself to decide if a molecule is polar. If there's only one bond, and that bond is polar, then the entire molecule will be polar, such as in HF. And HCl. You have a positive side and a negative side. Same thing along that lines, if you have one bond and that bond was nonpolar, such as in iodine, the entire molecule will be nonpolar. If you have several identical bonds around a central atom, and they're symmetrically arranged because there's no lone pair, then the molecule will be nonpolar, such as CF4. The bond between carbon and fluorine is polar, but the molecule is nonpolar because the fluorines are surrounding the carbon with no lone pairs. If you have several different atoms arranged around the central atom, it will always be a polar molecule due to the electrons being shared unsymmetrically, such as CH2O. And finally, if you have any lone pairs on the central atom, it will always result in the molecule being polar, such as in water. So looking at CCl4, go ahead and answer these two questions. Restart when you have them. If you look at the electronegativity chart, the carbon-chlorine bond is polar, so we have 4 polar bonds. But the molecule is not polar because you have the same atom all the way around with no lone pairs. And pause the video and try this one on your own. Looking at the chart, all the bonds are polar, and the molecule is polar due to the lone pair on nitrogen. Go ahead and draw the Lewis structures for these compounds and decide if the compound has a dipole moment. In other words, is it polar? HCl has one bond and the electronegativity difference is greater than 0.4. Chlorine was slightly negative, hydrogen slightly positive, so it is polar or it does have a dipole moment. Chlorine shares its electrons equally, so we do not draw an arrow and it's just nonpolar. SO3 displays resonance, but we don't need to draw all the resonance structures to answer the question. The arrows should be pointing towards oxygen. Notice that the oxygens are symmetrically arranged around sulfur, with no lone pairs, making SO3 not polar. And H2S, the arrow should be pointing towards sulfur, making sulfur slightly negative, hydrogen slightly positive, making the compound polar since we have a lone pair on the central atom. And the dipoles did not cancel out.